welcome to my project on oceanic exploration and its changes since the Cold War. At the height of the Cold War, conflict was at its greatest. Although there would never be any physical conflict, the political conflict was very hot, and we became very close to initiating combat. During this time, budget in science and technology was very high for both the Soviet Union and the United States. Both parties were constantly trying to get ahead of each other both militarily and politically, and as a result of that, many new technologies were born. Unimaginable things such as the internet, smartphones, nuclear capabilities, and sonar technology, just to list a few. Today, the budget for science and technology is much lower than it used to be. Nowadays, we rely on privately funded companies and organizations to be the innovators and creators of the world. For example, SpaceX is constantly performing and innovating in the aerospace field, and NASA can't keep up simply because of its low budget. Moreover, the NOAA, or National Oceanic and Atmospheric Administration, had a total of zero-sum budgeting for 2015. This means that even the small budget for NASA is still infinitely greater than that of the NOAA. The K-129 submarine is a Soviet submarine during the time of the Cold War. It is presumed to hold nuclear ICBMs that can fire if necessary, and highly confidential documents that, if found, could compromise a Soviet mission. The K-129 was lost at sea, and Soviet ships were spotted searching for it. After Soviet ships stopped searching for the K-129, the United States saw a new opportunity. A proposed mission that would cost $800 million at the time was made to build a ship capable of retrieving the wreck of the K-129 3 miles deep. This massive project is a good example of big science for oceanic exploration that is funded by the United States. The ship, named the Hughes Glomar Explorer, was said to be mining manganese deposits, and the actual mission was kept confidential. In 1974, the Explorer recovered a large piece of the K-129 and found 2 nuclear torpedoes and the bodies of 6 seamen, which they later buried on U.S. soil. Because of a minuscule amount of funding, an alarming 95% of the ocean remains unexplored. This statistic is unfathomable, considering the ocean makes up 71% of the Earth's entire surface, yet our understanding of it is still primitive. The ocean is a wondrous location filled with possible solutions to many of today's large issues such as drinkable water shortages, dwindling resources, world hunger, and global warming. On top of this, the ocean potentially holds a very large amount of undiscovered species of plants and animal life. Additionally, ocean exploration can potentially explain current unexplainable incidents such as the missing Malaysian airliner or the Amelia Earhart crash. Satellite technology cannot feasibly map the ocean floor because they receive and transmit radio waves which do not propagate well through the water. This is why we have little to no understanding of the ocean floor. Other methods have been proposed to map the ocean floor, but they are very time-consuming and expensive. These methods include sonar technology, which can allow us to see more details of the ocean floor. Another method used is multi-beam technology. This method allows multiple beams or pulses of sound to be transmitted over an area. In the image, you can see how the multi-beam technology compares to the original single beam of sonar. Lastly, side-scan sonar allows us to map areas of very deep waters. The side-scan sonar tows a dense apparatus capable of sending out sonar pulses and mapping deeper waters. Currently in development, the Exosuit is a new form of technology that allows a single human man to dive to depths over 300 meters. The suit maintains a constant 1 atmosphere of pressure at all depths. This is equivalent to the pressure we experience in the air every day. By splitting water molecules through a process called electrolysis, the exosuit is also capable of producing its own oxygen for breathing, and a chemical process is done to scrub away the carbon dioxide exhaust. The Nautilus is currently the world's leading program for ocean exploration. The Nautilus is a compact submersible vehicle that is controlled remotely by a team in Georgia for the purpose of exploration. The vehicle travels the depths with large headlights and a mounted camera, which it uses to livestream everything it does to their website, www.nautiluslive.org. Last, but certainly not least, is the Venus program, an alternate branch of the Nautilus. It features 2 underwater observatories. Venus observatories are used to persistently measure temperature, salinity, and pressure to provide useful data for the Nautilus team. That's all, folks. I hope you've enjoyed my presentation on ocean exploration. And remember, adventure is out there. If you have any questions, you may email them to me at ajulian345@gmail.com.